So first we will try to understand about linear search technique. Okay, before this, what is searching? Why do we have to do a searching? What is mean by the searching, right? So when you have a list or when you have an array with you with some set of elements, okay, you want to know whether this element which I am giving exists in this array or not. We know about searching, we do lot of searching, right? Given a, when you want to check result and you have a PDF document with you, you will do control F, right? You will press control F and you will give your roll number and check whether that is available or not. You are searching for a record in a PDF document. Same thing here, as simple as that. So given array elements, find out whether, and also a key element, find out whether this key element is present in this array or not. That is the task. So we have two ways of doing it. One way is linear search, the other way is binary search. Okay, linear search and binary search. So what is this linear search? Let's try to understand. This linear search is also called as sequential search. How does it works? If you see here, I have elements 10, 15, 30, 70 and so on, and the key given to me is 20. Key given to search is 20. So what? Linear means we do it in sequence. First check the first element, no. Second element, no. Third, then fourth, then fifth, sixth, seventh you found. Once you found it, you have to return the index. Once you find it, you will return the index of the location of that particular element. Wherever this element number 20 is found, you will print its index value. Okay, this is linear search algorithm. It is very simple technique. You have just to traverse through the array. You have to just to traverse through the entire array. Keep searching for elements, whether it is available at first place, second place, third, fourth, so on. At some place you will find. If it is not found, you may return -1. If the element is not found, you can return -1. And if the element is found, stop the process there and return its index. Return the index of that particular element. You can say the element is found at index +1 location. If index is 6 means 7th location, in the 7th place in the array. That way you can give the output. Okay, it is defined as a sequential search algorithm that starts at one end and goes through each element of the list until the desired element is found. Okay, we start from the 0 indexing and we keep increasing, keep searching for the element till the end. Wherever you found, you have to stop the process and you have to try to print the index of that. Okay, so this is a simple algorithm what we have, that is linear search. Now how do we what is the logic here? How do we write this? So it is very simple. You will read the array, int a of 5, just any number n or 5, whatever you say. You read the array value and then using scanf, for loop, that and all, you read the array value. After that, iterate over the array elements. How do we iterate over the array elements? Using for loop. So for I equal to 0, starting from 0, I less than n, that is n is your the number of elements in the array, I plus plus. So what you do here in open and close brackets, you write here if, and you have to read the key also. Read the key, the element which you want to search. If a of I, the first a of I means first time a of 0 is equal to key, if the element is found, right, print or return, you can write return the index I, return index I. Else it is not required, because if it is there it will return I, otherwise it will keep going here, I plus plus, again search, again I plus plus, again search, again I plus plus, right, and it has to break here. Once the element is found, we have to break it, because we have to come out of the loop and print saying that element has been found. Okay, this is the logic of binary search. Very simple technique. I think you all know this indirectly, without knowing that it is called as linear search algorithm. Okay, uh, we again, this is just to understand that. Now we will talk about the best case, average case, and worst case of this linear search algorithm. Okay, so when you know that you have a element array with 1000 elements, so it starts from 0 and 999. You have array A of 1000. Okay, and some key is given to you. Key is given as X. Suppose if that X is found, if the X is found in starting one or two locations like this, in starting two locations itself, if you found the X, then that is the best case. Why? Your for loop is break I 0, I less than n, I plus plus, right? This is iterating only 2 times and you are coming out. We are not spending so much of time in this for loop for iterating over every element 1, 2, 3, 4, so on. We are not going. You are getting the answer in the initial step itself. In that case, you have to know this is the best case of the linear search algorithm. If the element is found at the beginning itself. Now, what if the element is found at the end? Suppose the element which you are finding is at this location. See, this for loop has to run 1000 times and it has to check the if condition 1000 times. Okay, when the element is at the last location, I am talking about the worst case. When the element is at the last location, we are iterating this for loop for 1000 times. Unnecessarily, we are doing it, repeating this 1000 times. Okay, and you know the computation requires for running this 1000 times. It takes a lot of time to run it 1000 times. What if the array size is 10,000 and the element which you are searching is at 9989 location? Okay, again it's a problem. We have to repeat this so many number of times. Unnecessary checks. Simply repeating 1, 0, index 0, index 1, index 2, so on, check, always like this, right? So this is one drawback of linear search. The best case is okay. The average case is very, again, similar to worst case only. Suppose in this array of 1000 elements, the element which I am finding is at 700th location. If the element which I am finding is at 700th location, it's kind of worst case only. So we can see this as only two cases, best or both combined together as worst case. So the average case and the worst case are same for linear search. Only we have best case. That is if it is at the beginning of the array. If they are not same, almost same. Okay, that's what we say. We are almost same, right? Now this is the process what is happening in linear search algorithm. Okay, so how do we write? This is just code. I know you might see again that's a C programming, but not knowing it has to be done in C++. I have got this code. This is just to understand. Same thing can be done in C++. We will see that. See, int main, I have the array elements. I have a element 10, that is X, which I want to search, right? Then I am calling a function search with the name of the array, the number of elements in the array, and the element to be searched. Okay, I am passing these three arguments, name of the array, that is ARR, and then I am giving, that is address. Actually ARR means address, starting address. Okay, I am giving the starting address. Then n is the number of elements, and x is the key, that key which I have to find. So see, the logic is very simple. It is received here. After that, you see, for I is 0, I less than n, I plus plus, if a of I equal to x, return I, otherwise return -1. Otherwise return -1. I means here, what is returning here? I means index. Okay, so at which location we found the value x, that particular index will be returned. Then we wrote return -1. Right. So if the element is found, I will be returned, otherwise -1. Then in the main program, if result is -1, element is not present, otherwise element is present at the index. Okay. This way you can write the linear search. This is same in C++ as well. Nothing will change. This remains same here. Only this here we will have cout statement. Cout double quotes element is not present. Okay, this way we will be writing it, right? Next, how do you write this in C++? Element is present at index percentile d. We have to write like this: cout double quote element is present at index, then close this. You write the index value, that is result and semicolon. So it will give the element is present at the index and the result. So these two will come side by side. You can even use end s, okay, to give some space between index and the result value. It will insert a null character, so you will get the answer very clearly. Okay, so this is very simple searching technique, linear search. The drawback with this linear search is that the worst case of linear search, because unnecessarily, or it is not unnecessary, but simply we though when we know it is at the end, we are unnecessarily repeating it for 1000 times, and at the 1000th time you are able to find that element. Okay, so to avoid this drawback in the linear search, there is one more solution for this, that is binary search. So the next technique is binary search. Okay, let's try to understand what is this binary search. Okay, drawback of linear search, you understood that in worst case, though I know the element is at the end, but my logic is repeating it throughout all the elements it is traversing, 1 0 1 2 3 so on till 999, and then I am able to find out. So we are trying to reduce the time complexity of the linear search using this binary search technique. Only thing, the worst case I am repeating 1000 times, right? This 1000 we want to reduce it to some certain number, some x number of times only I want to repeat it, so that it is better than this 1000 times. Okay, that is your binary search technique. Let's understand how does this works. The precondition for this binary search is that given array, the given input array should be in sorted order. It should be in sorted order. Okay, array, you should not have some random order like this. Here if you see, we have 10, 15, 30, 70, 20, 90, we have in random order. So when the given input array is in random order, you can apply only linear search. But when the given array is in sorted order, only then you can apply binary search technique. That is the precondition here. Okay, so let's assume a sorted order 10, 20, indexing 0, 1, 2, 3, 4, 5, 6, 7. Okay, this is the array A. I have 8 elements in the array, and let's assume the key element which I want to find is 70. We'll see multiple cases. Assume the key element is 70. How does this binary search works? What binary search will do? It will assume this starting index as low. It will take low equal to 0. Then it will take another index high equal to n minus 1. Low equal to 0, high equal to n. What is n here? N is 8, number of elements in the array, that is 8. Okay, so find out low equal to 0, this is fine, high equal to n minus 1. So in this case it will be 7. Calculate mid, that is low, high plus low by 2. So here you get, again you have to take the floor. So 7 plus 0 by 2, it is 3, because integer it will become 3. So now we have low as 0, high as 7 and mid as 3. First time we have to do this like this. Now starts your actual logic of binary search. What we try to do is that we will try to find out whether the element which I am finding 70 is it in the, where is 3, index 3 is here. Okay, we will try to see whether this key element is towards left side of the key or towards right side of the key. Okay, we'll try to see if it is left side or right side. How? First step is we will check whether the mid element itself is the key or not. So the first condition will be if that a of mid, the mid value which I have now here, a of mid, let me write shortcut a of m. So if a of m itself is the key, then you return index. Then you return the index, whichever index it is found. Else, if you check, you verify whether this a of m, okay, whether this a of m, a of I here, yeah, a of m is less than key. A of m is less than key. Now you see what is the case here. What is a of m value? A of 3 is 40. 40 is less than key is 70. Right? If a of m is less than key, then you have to make your low value as m plus 1. So now this will become your low. Okay, so the low value changes to 4 and high value remains 7. Low value becomes 4, high value remains 7. Now what happened with this? With this one step, we are trying to focus only on this particular array. Only on this particular array. This is my low, this is my high. We are skipping identifying in this array. Middle element anyhow we have verified that it is not available. Then we are checking this. A of m is less than key. Then make your low as m plus 1. Suppose the key element which you are finding was 20. Then the third case. Else, what you have to do? If a of m is greater than key, if a of m is greater than key means 20 here and 40 here, right? In that case, 40 is greater than 20. So when that is the case, you have to make this high as this. You have to make high equal to m minus 1. So in that case, in the third case, this will happen. This will be your array for these 3 elements will be your. So your low will be at 10, your high will be at 30. So this will be the array of your focus. So what we are trying to do, by just calculating the mid value, we are doing some if conditional checks and we are identifying whether the element which I am finding out, is it on left hand side or is it on right hand side, so that I can reduce the number of iterations. I need not do it in the complete array like I am doing in linear search. Okay, so now when this becomes your low, in this case, our case it was 70, right? Our original case was 70. So in this case, we came to know that the element is at this location only, in this part array. Now what became your low? Low became 4, high became 7. Again repeat, again go back and calculate your mid value. So what is mid? 4 plus 7, 4 plus 7 by 2, 11 by 2, it is 5. So 5 becomes your mid. Again check whether the element which I am finding out, is it on left hand side or right hand side. If it is right hand side, this becomes your array 70 and 80. Like this we keep repeating it and we are trying to reduce this my array size, not array size but the focus area. I am trying to reduce the focus area. I am taking small locations like this. Then I came to 70, 80. Now this is my low and this is my high. Again calculate mid, again find out, ultimately you will get the answer. So in this way, with almost 50% reduction in the number of iterations, we are able to find out the element. Okay, this is how binary search works. I hope you understood this binary search concept, right? So we have to repeat the for loop. You have for loop there, and inside this you will have these 3 conditions, that low equal to 0 initially, high equal to mid, high equal to n minus 1, then you will write mid equal to L plus h by 2, you will write this, then you will write the condition if a of mid equal to key, right? You will return I. Else, if a of mid is greater than key, means your high will be reduced to m minus 1, that is mid minus 1. Else your low will be reduced to increased to mid plus 1. That way you are trying to reduce the problem size this side or this side. In this again you are focusing, again you are trying to partition this side or this side. Again in the small box, again you are partition checking this side or this side. If you keep doing this, at some point this first condition itself will give the answer. So with this process we are trying to reduce the what we say, the time complexity or the number of iterations what we are doing for binary search technique. Is it clear? I hope you understood. Right. Okay, let's see the code. Let's try to understand. This is just again existing code which I have taken, but you write in a single program, or you can. It is always a standard practice to write programs as functions. Okay, start whatever program you write. Even this I'll just use a sample example here about these functions. Why am I talking about functions? Right. Suppose you want to write a small program of addition of two numbers. So you will write generally like this. You will have a header file int main. Okay. Then you will declare variables int a comma b comma c. Then you will write c in a and b. Okay, I am writing in C++. You will write c in a comma b. Then after this you will write c equal to add of a comma b. You will be passing those values as functions, and you will next you will write here sorry, C out, right? Okay, I'm sorry. C out the sum of A and B is C, and you will write return 0 and semicolon. Then this is how you wrote a program, and here you are writing int add int x comma int y, and then here you will write int z equal to x plus y and return z. That's it. See, simple addition program which completes in just one line or 3-4 lines. We are trying to write the same thing as functions. We are having we are reading the input. I am calling a function. The control is being shifted here. It will do this task, return the values, and I am printing the value as C. Okay, so it is recommended practice to follow this. Whatever program you write, you please write it as functions. Okay, because in almost all the competitive exams or placement exams, they will be giving you the main function. Only this part will be left as blank. This code, this body of that function you have to fill. Remaining all will be given as this input will be given, reading input, calling the function, everything. This actual logic you have to fill. Most of the cases, in placement exams they give this type of questions where you have to fill only this part. Okay, so it is better always know this is okay. This is simple thing. What if you are passing array? What if you are passing pointer? Right, it becomes challenging in that case. So it is recommended to always follow this practice of writing program as functions. Right. So if you let us see the code here. So from int main, this is my array, and I am calculating size of the. How am I calculating size of array? You see n. See, yesterday we have discussed that when we give a as empty brackets, you can give like this. You can give like this. This dimension is not required when you are assigning the values in the array itself, in the program itself, right? We don't need the size of the array here. Dimension is not required. In this case, how do you find out? You have to use the size of operator. Size of operator. Size of ARR means how much memory is allocated for this variable ARR. So what compiler is doing? It is counting 1, 2, 3, 4, 5. So 5 into 4. So 20 bytes. So n value is nothing but 20 divided by size of A of 0. A of 0 means only one block, that is 4 bytes. So with this we are trying to find out 5, because we do not know the count here. We don't have any variable count here. So you have to write this very important statement when you're using functions for doing operations. Okay. Then x value which I want to find is 10. You may take it from the user, or you can directly write like this. I am calling a function binary search. I am giving the address of the array. I am giving the starting. This is low. This is low. This is my high, and this is my key, which I am passing here. Okay, I am giving low value. I am giving high value, and the key which I want to find out. So here you see array address is copied, low it is copied, high it is copied. What you are trying to do here? See, if low is less than or equal to high, if low is less than or equal to high, what is this condition, low less than or equal to high? Because you see, whenever we are doing in this example what we have seen just now, this is the mid element, this is low, this is high, right? If the element is found this side, we are making this as our h. If the element is found this side, we are making this element as our low. So at any point of time, this L should not cross H, or H should not cross S. Okay, for that this check. Then I am calculating mid. I am calculating mid. So this is one way. I was simply writing there low plus high by 2. So it is 7 by 2 means I was telling 3.5. But the standard, to avoid this 0.5s, you can write it like this: low plus high minus low by 2. Okay, same thing, you give low as 0, h as 7. See, what is mid value here? 0 plus 7 minus 0 by 2, same thing. Okay, this is the case when the h value, when the number of elements are 9, h becomes 8. So in that case 8, so it becomes 4 perfectly. Okay, anyway you can write it, anyhow it will convert to integer only. Then the first check, if array of mid is equal to the key, is the middle element the key which I am finding out? If that is the case, return the mid value. Return the mid means return the index. Mid means index here. Low is index 0. High is also index n minus 1. Mid is also index. So I am returning mid here. Otherwise, if a of mid is less than the key, then low becomes mid plus 1. So the second half, this half, this becomes our new low, and our high remains here only, h. Else high equal to mid minus 1. I am focusing on the first half, in this case only this half. So here is my L, here is my h. So I will be playing only in this part. This you see, I am repeating it always. I am repeating it always. Again from here it will go back. Again check this, again calculate. It will keep repeating. At certain point, with very less number of iteration, we will be able to find the index value. And after doing the full iteration, if we couldn't find the value, we have written minus 1. We have written minus 1. Okay. So then this the index value which is found here will be returned back here, and that is comes in result. Then if result is minus 1, element is not found. If it is found, it is present. Okay. So actually the underlying concept in this binary search is divide and conquer. This is a problem solving technique. Okay, there are many problem solving techniques. One among them is divide and conquer. I think you might have heard about greedy, right? Brute force, backtracking, dynamic programming, and divide and conquer. Like this, we have some techniques. These are problem solving techniques. This is required for you. I think you will have a course in your curriculum. But the underlying technique behind this binary search is divide and conquer. What is this divide and conquer? It has come from divide and rule policy. Divide the India into different states so that administration is very easy. Same thing. That full array what we have with us of size 100, for example, we are trying to divide it into and play with only on the second half alone, where our size is only 49 or maybe 50. Then again in this 50, again I am dividing into one more half, that is 25. Again in this 25 I am trying to divide into 13. In this 13 again I am taking both left and right side, I am having 7. That way I am trying to reduce the size of the array to locate the array element. So actually we are trying to divide this problem into small, dividing it more, divide further, divide. At the end we will find it. So finding out is conquering the value which we are asking. Okay, so after learning these problem solving techniques, you will understand that the technique used here is divide and conquer. And we also have one sorting technique called merge sort. Okay, this is also based on divide and conquer technique, right? So I hope you understood, you got about linear search and binary search concepts, right? So this is your binary search, and this is the code for your linear search. This is simplest one. The drawback with this linear search is that worst case one. Okay, here binary search, if you ask me what is the complexity, is just n log n. It is n log n. Why? This while loop is repeating n times. It is repeating n times, and log n just for this condition checking. Okay, since we are checking the condition, it is log n times, right? So time complexity is n log n. We will try to explore it, why it is n log n and in what cases, right? So with this we complete our linear search and binary search concept.